right. What did you learn about in that POGL that you did? Molarity. What is molarity? Okay, so that's in words how what it is. It actually is moles of solute divided by liters of solution. Okay, so its molarity is moles of solute. Now solute was what? That was one of the words we learned last time. What was solute? That's the thing being dissolved. Good. And solvent was then thing that's doing the dissolving, and solution is what? Results, right? Okay, so what I like to do is I want to go to a couple of FETs and show you a couple of FETs here really quick. I think I've got it so I can bring it up. Let's see. Yes. Okay, if it wants to come over. Come on, I want that one. All right, it's being a little ornery, so I'll just come over here and move it over. Doesn't want to come. So here we have a FET demonstration. This is the drink mix. We've got water. We can turn on the faucet. Maybe it doesn't like me because I have my eraser on my finger. Okay, so I'll just do it from over here. So I can turn on the faucet. Let's try it again. Come on. I can add solute. And this one has a color. Because it has a color, we can see it going on in there. Okay. I can add a solution to change it. I can take and find out what the concentration in moles per liter is. I can, let's see if it'll let me drain. I can drain some of it. I can put some more water in. And when I put more water in, notice what happened to the concentration. I can also have some evaporation taking place. And what happens to the concentration when I'm evaporating? It goes up. So if I add water, what happens to the concentration? It goes down. What if I remove water? It stays the same. Good. But I can take and add some more, what is this called? Drink mix? Solute, right? And it changes the concentration. So this is sort of what we were talking about last time. And then we went and we did a lab and we found out what a solution, a colloid, and a suspension were. Who can tell me what a suspension is? Yes? Okay, some of the particles float or fall out, right? The particles are big. Okay, and who else can give me a definition of a colloid? Yes? They're still big, but they stay in solution and they reflect light. What was that reflecting light called? Do you remember? It started with a T. Tyndall effect. Good. It's a Tyndall effect. So both solutions and colloids will give us a Tyndall effect. What's so important about the Tyndall effect? What does it help us discern between? So if I have two that look like solutions, but I shine a light through one and nothing happens, and I shine a light through the other and the light scatters, then I know even though they look clear or they look like a solution, the one is a colloid, right? Okay, so we're going to look at this other one. Oh, nope, hopefully I didn't just shut it down. If I did, we'll bring it back up. Looks like I might have shut it down. So go back here to the blog. I've got these linked to the blog, so you can go and play with them. So we're going to go to FET molarity right now. This one right here has to do with what the packet that you just did. Okay, and it has to do with the concentration. Now, you worked within your packet, your POGL packet, concentrations where it didn't have color, but it could still be more concentrated, right? We're using color here so we can visually cue on it too, but that doesn't mean that you're going to have a color. So we've got a drink mix here. We could pick a lot of different things. Maybe I want to do copper sulfate because that's something we would see in lab. So if I have copper sulfate and I've got my molarity, maybe I want to increase the volume, my solution molarity would go down, right? As long as I haven't added anything to it. If I decrease the solution volume, my concentration goes up. So if it's evaporated off, it goes up. If I add things to it, oh, wait a minute, there's a new word. What does saturated mean? I've got too much in there. That's when my kids have added too much sugar to their Kool-Aid and it goes to the bottom and you got the sugar down at the bottom. Or even as they're older now, if they add too much chocolate mix to the milk, you get that chocolate residue down at the bottom, okay? That's because it's saturated. I can't put any more into solution. So maybe I need to add some more liquid. Look at what happens. Just in a little bit of water change, I go from saturated to unsaturated. And unsaturated means I don't have anything left down at the bottom. I can put more in. So my molarity, notice my molarity here is changing. Notice the number. As I get weaker, my molarity does what? It becomes smaller. As my molarity gets more saturated, it gets more. Now notice, as I get more and more saturated, does it move? No. So once I hit that saturated point, that's as much as I can get into solution. Okay, I can go and change to a different nickel chloride. I can get a lot more into solution there. Okay, I can't even get where, let's see if I can get up to that 5. I can get up to the 5 if I just use a small amount of volume of liquid with a mole of concentration. So you can go through and pick different ones to go and do. This one's already saturated. How long does it take to get unsaturated? Whoa, I can't even get it unsaturated with full liter, so I got to put less in. Okay, so depending on the chemical you have, depends on how much you can dissolve in. Okay, I can put a lot of salt in solution before it starts to fall out. Sugar, I can put a lot in. If I try and put a lot of drink mix in, like chocolate in my milk, I can only put so much and then it starts falling out. So this has a whole bunch of different ones that you can go and play with, and I want you to be able to do that on your own time when you have some little bit of extra. Okay, so I'm going to bring up this right here. We're going to just sort of go into this a little bit. We're not going to spend very much time on this because we're just going to work on molarity today. So this is a review. We had the solute and our solvent, and we get solution, right? So I'm going to be using those vocabulary words a lot. There was something else we learned last time, miscible and immiscible. Who can tell me what those mean? Oh, don't cheat and look. See if you can remember. Mixable and not mixable, okay? They sound sort of the same, so that's what I would make sure I do there. Okay, concentrated and dilute is what we were working with today. So concentrated is a lot of stuff in a little bit of liquid. Okay, dilute is a lot of liquid with a little bit of stuff. Okay, so you had little pictures that you were able to draw. Now, the blue in here represents the solute particles, and the pink, the solvent. So the pink would be like the water, and the blue, and I would have flipped the colors because I would think blue water, but that's okay. But you can see how that sort of changes. So we got our solute plus our solvent gives a solution. I'm going to keep pounding that into your head. Our concentration is always solute divided by solvent or solute divided by solution. Okay, so for molarity, we're going to do moles divided by liters, and that's a solution. So here's an example problem. This is not the example problem that's there, so if you want to add it, you can to another paper. This is a nickel chloride. Nickel chloride is green. It's down here by the side over here. If I add enough nickel chloride, and that they did the L, they chose a thing here, that should be a small L, dot 6 waters. That means 6 waters are already attached to it. and enough water to make 250 milliliters of solution, calculate the molarity. So the first thing we have to do is calculate the molarity of nickel chloride. Okay, so if I have 5 grams, I'm going to add up the nickel, 2 chlorines, 12 hydrogens, and 6 oxygens. That's how that works, okay? And I'm going to get this mass. I'm going to take 5 divided by that. I've got the number of moles, and it shouldn't be m, it should be moles there. Sorry, I need to go back and fix that. Calculate the molarity. So I just take the moles, divide it by liters, and I've got my molarity, and that should be a capital M on that one. So notice the brackets here. The brackets denote concentration. So whenever I put brackets around something, if I have FeCl3, if I put brackets around it, that means I'm looking at a concentration. All right? So what mass of oxalic acid, and this is oxalic acid, is required to make 250 milliliters of a 0.5 molar solution? So I got to rearrange stuff here. Now I want to find out mass. This is what they do in the hospitals when they go and they ask for a certain molarity, or they're usually asking for a certain percentage, and we'll get to that later. Concentration. We're going to rearrange our equation so it's moles equals molarity times volume. Change the milliliters to liters. So move the decimal by 3 or divide it by 1,000. Second thing, we just plug it in and calculate it. So we've got molarity times liters. The liters will cancel out. We get moles. Then we use, just like we've done before, the mole map to convert from moles to grams. And we know how much to put in. So we put that amount into that flask that you saw on the other page. It's called a volumetric flask. And then we would fill it up till the meniscus is at that one line that's on there. Okay? All right. Let's see if you can figure this out. Just from what we've done, this is a check. How many grams of NaOH are required to prepare 400 milliliters of 3 molar NaOH? So what's the first step? What do you need to do first? Change to liters, so move the decimal by 3, so it's 0.4 liters. Okay, now what? Liters times molarity, so 0.4 times 3 is 1.2, right? That's how many moles. Now how do I change from moles to grams? Add up on the chart, right? And sodium, an oxygen, and a hydrogen's about 40. So 1.2 times about 40 is going to be what? 48. That's the only one that's close, right? 1.2 is just a little bit bigger than 40. Okay, it should be highlighting 48. Okay, we have to make sure that when we make a molar solution, we put the solid in before and then put the water in up to the meniscus. This is a volumetric flask. If we don't, and we put the water up to that level and then put the solid in, we end up with this much extra water. And then we have no idea what we've got as far as how much total solution we have. So we have to add the water after we add the solid. Now, a lot of times we'll put a little bit of water down here in the bottom, because if we don't, what happens is the solid sticks to the bottom of the volumetric flask and then doesn't dissolve. So we put a little bit of water in, put our solid, and then fill it up to the meniscus, or the line with the meniscus. Okay. So I'm going to go back down now to your paper, and let's do one example here with you, your practice. And mine folded weird, so we're just going to pretend that it works. I'm going to bring it down to the bottom so I can push it up. Okay, we good? All right, I'm going to bring that up so it's out of the way here and enlarge it. Okay, so first it says, what is the molarity if I have that many moles with that many liters? Well, that's pretty easy, right? Molarity is equal to moles divided by liters. Oh, okay. So 3.81 moles divided by 1.56 liters. And this is where we need our calculator, or if you don't have a calculator, you can use your phone, and this is simple calculation. 3.18 divided by 1.656, 2.44, okay. And the symbol for molarity is a capital M with the points like mountains. Okay? All right, we'd circle our answer, of course, or square it, one of the two, so I can find it fast. The next one is, what is the molarity of the solution if I have this many grams of this in this? Okay, so I got some conversions to do here. So I'm going to take that 35.6 grams of calcium chloride, it's written correctly, and I first have got to change it to moles. So I'm going to use my little factor label. I'm going to look up on the periodic table, and I find out calcium is 40.078. And I look up chlorine, and I have two of them, and they're 35.453. And I've got a lot of these memorized because I've had to do them a lot. You'll know which ones I have memorized and which ones I don't by the ones we use a lot. I'm going to add that up. So let's add that up. Let's get a mass for this. We always want to add the mass to 5 sig figs. Yes, sir. 110.78? 978. Okay, we'll take 6. That's all right. That's how many grams are in 1 mole. I want to get rid of grams. Yes. 984. So let's just do this, and we'll all be the same. That's why 5 is nice to round to. Okay, so on this one, we want to get rid of it, so we put it on the bottom, grams, and we put 1 mole on the top. Okay, so we want to get rid of grams. We got rid of grams. It will cross out. And we put that through our calculator, and what do we get? 0.32. Give me one more. 1. And that's how many moles CaCl2. The other thing I need to do is I need to convert that into liters. I can move the decimal 3 or divide it by 1,000. Doesn't matter which. And I end up with liters, right? So if I take this and I divide it by the liters, and you'll see me using a cursive L just because this one right here sometimes gets confused with other symbols. And we get what for our overall molarity? 0.584. Okay, and that's capital M, and I do put CaCl2 because I want to know what is the molarity of. Okay? All right, now, there's more stuff in your notes. We're not going to go in any farther right now. We're going to stop. We're going to practice molarity. So what you picked up as you came in was a worksheet, and the worksheet is all on molarity. And guess what? We were really nice, and we put the answers at the bottom so you can cross them out as you get them. Now, when you get to the last one, you can't just put the answer. You've got to show me some work. Okay? We didn't put it +1, but we did give you the answers down at the bottom. So by the end of today, I would like to see, we've got plenty of time. You've got half an hour. This should be done really fast. I would like to see that in. I would like to see your lab from last time in. I would like to see your molarity POGL in, and I would like to see your phase diagram sheet in. Okay, if you need help, come on up and get it. If there's a lot that end up coming up to me, I'll move to the U, and you can get some help at the U. Okay? We good? All right, let's go.